Hi students, this is AJ sir. Let's study 9th standard ICSE Math exercise 9B from the chapter Congruency of Triangles. Geometry, you love geometry. So let's dive in with sum number 2, an IMP sum. We've got two different diagrams, and in each of these we have to prove two things. First one, prove the two triangles congruent, and second one, find the angles of a particular triangle. Let's focus on the first diagram here. So what is given is that ABCD is a square. That means all four sides are equal. And also APB is an equilateral triangle. That means this side is equal to this side is equal to this side. So we have to prove these two triangles congruent. Now, we've got this side equal to this side, and also this side is equal to this side. I need one more thing. Well, I know that the total angle here is 90 degrees, out of which this is 60 degrees because it's an equilateral triangle. So how much is this then? 90 minus 60, 30 degrees. Similarly, this is also 30 degrees. So that means these two angles are equal. So by SAS test, SAS, these two triangles are congruent. These are the statements. Now we have to find the angles of triangle DBC. First of all, I know that this total angle is 90, angles of a square. In this triangle DAP, we found that this is 30 and it's an isosceles triangle. So I can assume this angle to be equal to this angle is equal to, let's say, X and X. So by angle sum property, this plus 30 is equal to 180. So this is gonna be 75 degrees. So this will be 90 minus 75, that is 15 degrees. Similarly, this will also be 15 degrees, and by angle sum property you can find this angle as 150 degrees. Here are the statements. Pause it and use it to solve it. Keep looking at the diagram to understand each step. Write the reasons. Solve exactly the way I am. This symbol means similarly. I'll be sending you pics of these statements as well. Now, Roman number 2 will be for homework. The second diagram will be for homework. Even there you have to prove Roman number 1 and Roman number 2. Draw diagrams, freehand, big diagrams. Now let's do the fourth sum. The diagram is not given. Getting the diagram right is very important. Well, the fourth sum is too easy, so let's do the third sum. So we have a right angle triangle ABC, and we have got squares PBAQ and ACRS. The diagram looks complicated, but we simply have to prove that triangle AQC and ABS as congruent. So the best way to deal with such a sum is draw the triangles separately. It makes it easy for us to visualize and decide which test to use here. So what do we have here? Well, I can say that this side is equal to this side because sides of the same square. So that's AQ and this is AB, so that goes here. Okay. Next, I know that this side is equal to this side, again sides of a square. So AS belongs to this triangle and AC belongs to this triangle. I need one more thing. Now, this is 90 degrees. So if I assume this to be X, so this whole angle is 90 plus X. So let me write this angle QAC as 90 plus X. 90 plus X. Similarly, this angle is 90 and I assume this as X. So this whole angle is 90 plus X. That means angle SAB is also 90 plus X. This happened because this small angle is common to both of these angles. Hence I was able to exploit it, and now I can prove them congruent by SAS test. So these are the statements for the proof of congruency, SAS test. Now Roman number 2 is prove CQ is equal to BS. CQ and BS. Now this is the most challenging part of this sum. How do we prove them equal? Well, since the two triangles are congruent, so their corresponding sides should also be equal. So by CPCT, done. Now in the sixth sum, they have mentioned that it's a parallelogram. That means opposite sides are equal as well as parallel to each other. This is a diagonal. Now angle A, that is BAD, was an obtuse angle, but point X is such that angle XAD is 90, and similarly angle YCB is 90 as given in the question. I have to prove XA is equal to YC, which can be proved by CPCT. That means I have to take two triangles. Now I can take these two triangles, but let me try these two. What do we have here? I've got side equal to side. Opposite sides of parallelogram are equal, of course. 90, 90, so angle is equal. I need one more thing. How about this angle equal to this angle, alternate angles? So ASA test of congruency. So by CPCT, they are equal. Proved. Here are the statements. Now the eighth sum. So here what's given is that AB is equal to PQ. AD is equal to PS. By the way, AD and PS are medians. That means D is the midpoint of BC and S is the midpoint of QR. And also the whole base BC is equal to the whole base QR. We have to prove these two big triangles congruent, for which I already have two things: side side and side side. I need one more thing. So first I will focus on the small triangles ABD and PQS. Let's prove these two triangles congruent. How? Well, side is equal to side is equal to side given. Now if whole BC is equal to whole QR, then half of BC will be equal to half of QR. That means BD will be equal to QS, because BD is half of BC and QS is half of QR. So these two triangles are congruent by SSS test. That means this angle is congruent to this angle by CPCT. And now we can use the big triangles, and the big triangles will be congruent by SAS test. Here are the statements. Now the 10th sum is very easy. First of all, a lot has been given. We have to prove this as 90 degrees. Well, prove these two triangles congruent, because side, side, given, side, side, equal, and common side. So SSS test. That means these two angles are equal. Let them be X and X. But they form a linear pair. That means each is 90 degrees. Now Roman number 2, prove these two triangles congruent. Again, side, side is given. Common side exists. And since this is 90, so by linear pair, this is also 90 and this is also 90. So these two angles are equal. That means, again, SAS test. Here, by the way, it was SSS test, and here it is SAS test of congruency. And then, finally, Roman number 3, AD is equal to CD by CPCT. These are the steps. Make sure you solve exactly the way I am teaching you. You wish that all sums were like this in exam, isn't it? Now the 12th sum. So here they've given that AB is equal to BC. This whole thing is equal to this whole thing. These are perpendiculars. We have to prove these perpendiculars as equal. Well, we'll have to select the triangles wisely and draw them separately to make it easy. I'm taking triangle ABD and BEC because they have AD and CE respectively for CPCT. Now AB is equal to BC given, and this is 90 and 90 given. I need one more thing. Well, this seems to be a common angle. Let's check. Yup, this angle is equal to this angle. So which test is this? SAA test. So by CPCT, this is equal to this. Here are the statements. In the 13th sum, it's given that PQRS is a parallelogram and L and M are points, but they are not midpoints. It's just that PL is equal to MR. And we have to prove that ML and SQ, they bisect each other. So if we imagine this point to be N, we have to prove MN is equal to NL and SN is equal to NQ. That's what we have to prove, which will obviously be CPCT, for which I have to prove these two triangles congruent. But how? Well, I have vertically opposite angles, I have alternate angles, but I need one more thing. I have another alternate angle, but there is no AAA test. I need a side. Then once I prove them congruent, I can say this is equal to this CPCT and this is equal to this CPCT, and the sum will be solved. That means somehow I have to prove this equal to this. Now I know that full SR is equal to PQ. That's right. Let me write it. SR is equal to PQ, opposite sides of parallelogram. Yeah, SR is equal to PQ. Now out of that, PL is equal to MR. So PL is equal to let me write MR is equal to PL then. MR is equal to PL given. So if I subtract them, what do I get? I'm getting SR minus ML, SR minus MR. What is SR minus MR? SR minus MR is SM. So this becomes SM is equal to, what is PQ minus PL? PQ minus PL is LQ. LQ. So I just proved that this side is equal to this side. So now I will be able to prove the congruency and finish the sum. These are the further statements. Vertically opposite angle, you can write like this. Alternate angles, write the parallel lines also. Don't forget to write the final statement here. Now read the 16th question. The diagram is not given. Try to draw the diagram on your own. Pause and try to draw the diagram on your own. That is the challenging part in such sums. The sum itself is very easy, but if you get the diagram wrong, the whole sum goes wrong. So you need to train yourself to draw correct diagrams as well. Now, ready? Okay, here. Is this what you drew? If yes, then that's good. If not, then you just lost 3 marks unnecessarily, because now it's such an easy sum. On the opposite sides of line segment AB, we have two perpendiculars. That means this is 90 and this is 90, and they are equal. And we have to prove that CD bisects AB. That means we have to prove DO is equal to OC and AO is equal to OB. So simply we have to prove these two triangles congruent, which is pretty straightforward. We've got 90, 90, we've got side, side, and we've got angle, angle, vertically opposite angle. So that's SAA test. And then by CPCT, we can prove what is asked. Here are the statements. Now again, the 17th sum, diagram is not given. Can you draw it? Try it. You want ready-made diagrams? That won't help you in exams. You need to learn to draw diagrams on your own. Now here, it's an isosceles triangle. AB is equal to AC. Also, BO is an angle bisector of this angle and CO is the angle bisector of this angle. First of all, we have to prove that BO is equal to OC. Well, it's an isosceles triangle. That means the big angle is equal to big angle. That means the small angle will also be equal to the small angle. So now again, this makes triangle OBC an isosceles triangle. So OB is equal to OC. Isosceles triangle property. Now Roman number 2, prove that AO bisects this angle. So I have to prove this angle is equal to this angle, CPCT. So which two triangles should I take? Let's take triangle ABO and ACO. That's one option. I've got side equal to side, angle equal to angle. No, this we have to prove. How can you take it? That's why I marked it with red. It's not given. Okay, so side equal to side, and we have proved side equal to side, and we have common side as well. Of course, we could have used angle equal to angle too. There are so many ways to solve this sum. I'm going to use Sss Test, and by CPCT, this is equal to this, and the sum is over. Easier said than done. Writing proper statements is important. Try to write it on your own and then compare it with my statements. Let's see if you have been trained well by now to write the perfect statements with reasons. Here are the statements. So, will you get 4 out of 4 in this sum? Now in the 19th sum, there's a rhombus, and inside the rhombus we are taking point O randomly anyway. I purposely didn't take it in the center because they've not mentioned anything like that, and we should never assume anything. So I took it here, and it's equidistant from vertices D and B. That means OD is equal to OB. Also, all sides of a rhombus are equal. That's a property. We have to prove that AOC is a straight line. That means we have to prove that angle this plus angle this is 180. We have to prove it's a linear pair. If I can prove it's a linear pair, that means AOC is a straight line and the sum is over. So how do I prove this to be 180 degrees? Well, first I will prove this triangle congruent to this triangle by Sss test. That means this angle is equal to this angle. Similarly, I will say similarly this triangle is congruent to this triangle. That means this whole angle is equal to this whole angle. Now the sum of all 4 angles, that is sum of angles around the point, is 360. So let's assume this is x, x, y and y. That means 2x plus 2y is 360. That means x plus y is 180. That means this whole angle is 180, hence proved. Here's the solution.